to adding and subtracting polynomials. It's been a hot minute since we've made a video, but it is all good. So we are going to start just by doing a quick warm-up and remembering how to combine like terms. So remember, with combining like terms, you want to look for the terms that have the same variable to the same power. So negative 2x and 7x would be like terms, but negative 2x and 3 would not, because the 3 does not have an x. So negative 2 plus 7 would give me a positive 5, and we keep the x. And then positive 3 minus 9 would give me negative 6. So it would be 5x minus 6. So then for number 2, we are going to multiply and distribute. So negative 6 times 3x would give me negative 18x, and negative 6 times negative 4 would give me a positive 24. So that would give us negative 18x plus 24. Then for number 3, we have this little negative sign, and keep in mind that's like a negative 1, so we have to actually distribute it to everything in the parentheses. So this would become 7 minus 2x minus 8, because it's negative 1 times 2x, negative 1 times 8, and then that minus 4 stays. Then you can combine your like terms. So in this case, negative 2x doesn't combine with anything, but we have a positive 7, a negative 8, which would give us negative 1, and then negative 4, which would give us negative 5. So 7 minus 8 minus 4 would give us negative 5. So for the last one, we're going to have to distribute twice. So 5 times 4x would give us 20x, and 5 times negative 1 would give us negative 5. And then negative 2 times 8x would give us negative 16x, and negative 2 times 6 would give us negative 12. So then if we are combining these like terms, we would have 20x minus 16x, which would give us 4x, and then negative 5 minus 12, which would give us negative 17. So getting into some vocabulary that you definitely need to know. Our first one is a monomial, and this is our fancy math definition, that it's a real number, variable, or product of a real number and variables with whole number exponents. And so really what that means is it could be 16, and that's a monomial. You could have just z, and that's a monomial, or a negative 3c squared, and that's a monomial, or 2.5xy to the 7th, and that's a monomial. But things that are not monomials, that almost looks like a W, would be like 3x plus 1, or 5x squared minus 3. They're adding these operation signs in there. So a monomial is just one little thing. So we are first going to simplify the expressions by adding and subtracting our like terms. So 6g to the 4th plus 2g to the 4th. Since they both have g to the 4th, I know I can just add them. So 6 plus 2 is 8. And then we keep the g to the 4th. So then for this one, we have a cubed c for both of these, which means we can just combine them as we want. So 5 minus 7 gives us negative 2, and then we keep the variables exactly as they are because they're the same. So for example 2, we need to simplify each sum. And so when we are adding, it's pretty easy because we can just look for our like terms. We have 8a squared and 5a squared, and all of this is getting added. So 8 plus 5 would give us 13a squared. Then we would have 3a plus negative 7a. So 3a minus 7a would give us negative 4a. And then we would have positive 9 minus 4, which is a positive 5. Okay, so remember, when you're combining like terms, you're just looking for the same variable to the same exponent. Whether it's one or two variables all getting multiplied doesn't matter, as long as the variables are the same. So for number 2, we're still adding, so that makes our life easier, but be careful because they have this 3 first and negative 2 squared in the other one. So if this is confusing to you, I would recommend rewriting it in standard form, which is technically your highest exponent to your lowest exponent. So if I were to rewrite this, I could have 6x to the 4th, because that's my highest exponent. Then I have a negative x squared and a positive 3. And then I'm going to be adding this entire thing, and I'm going to try and put it in the same order. And another thing you can do too, if you don't like adding horizontally, is to add vertically. This is going to be plus negative 2x squared. Oh, never mind. So we are going to add this negative 2x squared plus x to the fourth minus 11, but we are going to rearrange it so that we can just line them up directly. So x to the fourth should go under x to the fourth. Oops, why is my pen not writing? Then we would have negative 2x squared and negative 11. And for some people, it just makes it easier to stack them on top, which I don't have much space for this to actually write my answer underneath. But for some people, it helps to stack them on top of each other because then your like terms are lined up, but it can cause you issues if you have, let's say, an x cubed and there's not one in the other one, then there's not a spot for you to actually add them unless you write a 0x cubed or something. But 6x to the fourth plus x to the fourth would give us 7x to the fourth. Come on. Then negative x squared minus 2x squared would give us negative 3x squared. And then 3 minus 11 would give us negative 8. Yes, okay, I had a doubt on my mental math. All right, so then for example 3, we are going to simplify the difference, but you need to be careful because we are simplifying and it is a difference. You have to distribute that negative 1 that is there. Okay, so that would give us, I just like personally rewrite it because I find it easier, but some people do not. My pen is acting funny. 3c squared minus 8c minus 1. So everything in that first one gets to stay exactly the same, but then all of the signs in the second one will change because negative 1 times 7 makes it negative 7. Negative 1 times negative 2 makes it a positive 2, and negative 1 times 4 makes it a negative 4. So this is going to be minus 7c squared plus 2c minus 4. So then combining our like terms, we have 3c squared minus 7c squared. So that would give us negative 4c squared. Then we would have negative 8c plus 2c, which would give us negative 6c. And then negative 1 minus 4 would give us negative 5. Okay, so again, you're still just combining your like terms. You just have to make sure you're careful of your signs. So we'll do it again with this one. We have negative 6z to the fifth plus 4z minus 3, but then we have our minus sign, so that tells me, hey, everything's going to switch. So it's going to be now, instead of 2z to the fifth, a negative 2z to the fifth. And instead of positive 9z, it's going to be negative 9z squared. Instead of negative 3z, it's a positive 3z, and instead of negative 1, it's a positive 1. Again, we are multiplying that negative 1 to everything. So then, combining like terms, we want to look for our highest exponent, which is this z to the fifth. So negative 6 minus 2 would give us negative 8z to the fifth. Then we would have, let's see, next highest exponent, we have z, the constant, z squared. So that would have to come next. So negative 9z squared is all by its onesies. Then we have 4z plus 3z, so that would be a 7z. And then we have negative 3 plus 1, which is negative 2. Okay. Trying to make sure I don't run out of space. All right. So for part C, we have two rectangles. One is bigger than the other. The area of the larger rectangle is x squared plus 16x plus 64, and the area of the smaller rectangle is x squared. How much bigger is the area of the larger triangle? Draw a picture. So if I had a rectangle, boop, 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 and its area was x squared plus 16x plus 64, And then I had a smaller little rectangle over here that had an area of x squared, and I want to figure out how much bigger is it. I'm going to have to do one of my 4 basic operations: addition, subtraction, multiplication, or division. Since it's a difference, though, we know it is going to be subtraction, so we're going to do x squared plus 16x plus 64 minus x squared. And you notice when you subtract x squared, it just cancels out with the x squared in there, and we know that the bigger rectangle is 16x plus 64 bigger than the smaller rectangle. Keep in mind that we do not know what the value of x is, so this would be an actual number once we knew what x was. Okay, so a polynomial is a monomial or a sum of monomials. So if you go back up and look at your monomial definition and you wrote down the non-examples, notice that a polynomial is made up of a bunch of little terms, and the only difference is it has operation signs. So when you look at a polynomial, if you're trying to find the terms, the easiest way is just kind of put a comma before every operation sign, because then it gives you the sign and the terms within it. Now, standard form, I know I've already been talking about it, but standard form puts the degrees of your monomials from highest to lowest. And again, if the definition doesn't work for you, just rewrite it. Exponents, highest to lowest. So instead of, let's do 3x minus 2x squared plus 4. If I were to actually put it into standard form, it would be negative 2x squared plus 3x plus 4, because you move the terms and keep the signs that are with them. Okay? Standard form. All right. So then the degree of a polynomial is your highest degree of any monomial. So when it's in standard form, it's really nice because it's just the first term. What is going on with my pen? So in this case, the highest degree, if we come back to our example, would be a degree of 2 in this case. Okay, so for example 4, we have the polynomial 7x plus 2 minus 5x cubed minus 4x squared. And we want to write it in standard form. So remember, we want our highest exponent first. So when we look at this, our highest exponent is going to be a 3. So if you notice with that x cubed, there is a negative sign in front of it. So we would have negative 5x cubed. And then from the 3, the next lowest exponent would be the 2. So then the 2, notice that term has a negative with it again. So you keep the negative and you write it, negative 4x squared. Then the next highest would just be x, because it's like x to the first power. So then we would have that 7x. And since there's no sign, we know it is a positive 7x. And then last but not least, you have your constants, which is just your regular numbers. So we would have plus 2 at the end. Okay? Oh, goodness. There we go. All right. So we want to know what is the degree of the polynomial. Remember, the degree is your highest exponent. So that would be related to this 3 up in here. Oops. Ah, no. I failed. But since our highest exponent is a 3, we know that classifying by the degree that this would be a cubic polynomial. Well, so the degree of the polynomial is 3, which makes it a cubic polynomial. Okay? So when we talk about polynomials, we classify them either by their degree, which is their highest exponent, or the number of terms they have. So if the degree is 0, then it is just a constant. If it's 1, then it's linear. If it's 2, it's quadratic. If it's 3, it's cubic. And then with our number of terms, by the way, you do need to know all of the vocabulary in here, so make sure that you know it. But when you're classifying by number of terms, if it's 1, it's monomial. Look at your prefix, mono. If it's 2, it's binomial. And if it's 3, it's a trinomial. Okay. And this will make your life much easier if you know these terms now, because when we get farther along, you're going to get confused if you don't know what they mean. So we're going to do A through H real quick, and we're going to write them in standard form and then name it by its degree and number of terms. So I'm actually going to scroll back up. That way you guys can still see it. But we have negative 8c plus 4c cubed. So to write it in standard form, I have to have my highest exponent. So that would be 4c cubed minus 8c. Oops, minus 8c. So since my highest degree is a 3, that means this is cubic. And then we have two terms, because you notice we have 1, 2, because you want to put those little commas in there. So that would make this 2 terms a binomial. Oh, goodness. Okay, so then for B, writing it in order, we would want our highest exponent first. So that would be negative w squared. Then we would have 5w, so positive 5w minus 3. Now, since this is or has a 2 for the highest degree, then that would give us a quadratic function. And then if you notice, we have 1, 2, 3 terms, so that would give us a trinomial. Okay. So then with C, it's just negative 7. It's in standard form, so we can't do anything with it. It is a constant, and it is a monomial. Okay. So then for D, we have negative 9 plus 8h, so that would be 8h minus 9 for standard form. So then my highest, or my degree would be 1, because h is to the first power, so that means it is linear, so it would make a line. And with it being linear, and this polynomial having 2 terms, that would also make it a binomial. Okay. So then for E, F, G, H, for E, we have negative 3y to the 4th plus 6y to the 5th minus 2y to the 5th minus 1. So notice we have 2y to the 5ths right in here. So negative 6 minus 2, you should always simplify before you write in standard form. But 6 minus 2 would give us 4y to the 5th. Then we would keep that plus 3y to the 4th minus 1. And so then our degree is 5, and we actually don't have a name for it. So you can say degree is 5. And then its number of terms would be a 3, so that is a trinomial. Okay? So then for F, we have x squared plus 7x plus 3x plus 21. Again, we can combine 7x plus 3x. That would give us 10x. So we'd have x squared plus 10x plus 21. So if you notice, our degree in this case would be 2. That makes it a quadratic. And then because of that and it having 3 terms, the 3 terms makes it a trinomial. Okay. For the next one, x squared plus 2x plus 2x plus 4, we're going to add our 2 x's, so that would give us 4x, and then we can keep the other stuff that's around it. My highest exponent is a 2, and so that would make this also a quadratic. And then this also has 3 terms, so this would be a trinomial. And again, if you are not seeing these terms, it is almost as if you just, it is almost like you just ignore your operation signs for a second. Well, not ignore them, but Just space them out, and each individual piece around the addition or subtraction signs will be your different terms. Okay. All right, so last one, we have x squared minus 4x minus 3x plus 12. And so negative 4x minus 3x, oh, there it goes, would be negative 7x. And so then we would have x squared minus 7x plus 12. Our degree is 2, which makes this a quadratic. And we have 1, 2, 3 terms again, so this is a trinomial. Okay. Example 6, we have the perimeter of a trapezoid is 19x plus 1. What is the missing length? So if you think about it, perimeter is the distance all the way around a shape, correct? So that means that technically whatever goes on this missing side is going to add with these other 3 sides to get 19x plus 1. So first what I'm going to do is add them all. 3x plus 4 plus 3x plus 4 plus 8x minus 9. So if I add all of these, we would have 3x plus 3x, which is 6x, and 6x plus 8x gives us 14x. And then 4 plus 4 is 8, and 8 minus 9 would give us negative 1. So then we know that these 3 sides would be 14x minus 1, but we have that the total is 19x plus 1. So then we're going to have 19x plus 1 minus the quantity 14x minus 1. So if you write it this way, it'll just keep you safe from messing your signs up too much, because if you put the parentheses around the entire quantity, then you won't forget to distribute the negative to everything. So then this becomes 19x plus 1 minus 14x plus 1. I don't know what my pen is doing today. So 19x minus 14x would give us 5x, and then 1 plus 1 would give us 2. So we know that the missing side would have to be 5x plus 2. For example 7, we need to circle the error and correct the mistake. So if we notice we have 2a squared plus 7a plus 5, 2a squared plus 7a plus 5, minus 3a squared minus 4a plus 5, minus 3a squared minus 4a plus 5. Wait a second. We have a negative sign right here, which tells us that all of the signs in here need to change. So that means that this should be a positive 4a, and this should be a negative 5. Okay? So the closure question is, how are the processes of adding and subtracting polynomials different? And the main difference is that when subtracting, you have to distribute the negative sign, or the negative 1. Okay, so that is the end of adding and subtracting polynomials. If you have any questions, please feel free to ask either in the comments below or in person, whatever it may be. Please don't overthink this. Just remember, you're adding and subtracting, combining like terms, distributing negative signs. You've done all this stuff before. So please like and subscribe if this video was helpful to you. If you have any further questions, feel free to ask.